On this video, we're just going to work some examples of problems that go along with dilutions. Okay, in this very first example we're going to look at, linearity on the instrument was exceeded. The tech prepared a dilution of 5 milliliters of serum and 15 milliliters of water. The sample was reran after the sample was diluted down, and the tech ended up with 250 milligrams per deciliter as a result. So what should the tech report out as the final result? So what's the first thing that we've got to do in order to figure out what that final result is? The first thing we have to do is find the ratio. Well, how are we going to do that? We're going to use the information that's given. We're going to use the 5 milliliters of serum and the 15 milliliters of water, because the 5 milliliters of serum counts for 1 part and the serum counts for so many parts. Well, that's what we got to figure out. So we're going to take 15 and divide it by 5, and that's going to give us 3. So that's going to tell us how many parts of water we have. We're going to have 3 parts of water. So we can put 3 up here. So we solved that. So in order to get our ratio, we have to have total parts, right? So it would be 3 parts plus our 1 part of serum. So in order to get total parts, we really need to add that 1 to our 3 to get 4. So now do we have our denominator or our dilution factor where we can write out our total dilution ratio? Yes. This is our dilution ratio for this dilution. It's a 1:4 dilution. Okay. Now that we have our dilution ratio, we know our dilution factor. So can we go back to the original question? What should the tech report out? The sample was reran and we ended up with 250 on the diluted sample. Well, what did we learn when we ended up diluting a sample down? You've got to multiply the result of your diluted sample by the dilution factor. So our dilution factor is 4. So we have to multiply it by the result of the diluted sample. So that would be 4 times 250, and that is 1,000. So our actual result would be 1,000 milligrams per deciliter. On this next example, we're going to be solving a serial dilution problem. So you are given that you have a serial dilution with a ratio of 1 to 2, and it's asking you what would be the ratio of tube 5. And what I usually do to set up these problems is I go ahead and write out my tube numbers. I go 1, 2, 3, 4, 5. So I know I have 5 tubes. Well, on tube 1, we know our very first dilution is a 1 to 2. And we learned that when you do serial dilutions, you have to multiply all the tubes by the dilution factor. And in this particular case, our dilution factor is 2. So we can go ahead and multiply 2 times our dilution factor of 2 to get our ratio for tube 2. So tube 2 would be a ratio of 1 to 4. Okay, in order to get the ratio for tube 3, we're going to again have to multiply by the dilution factor of 2. 2 times 4 is 8, so you can move that down. To get the dilution ratio for tube 4, you would have to again multiply by 2, our dilution factor. 8 times 2 is 16. You can move that down. So tube 4 would have a ratio of 1 to 16. Again, we're going to multiply finally by dilution factor of 2. 2 times 16 is 32. So then this is the answer that we're looking for, because it's asking us what would be the ratio in tube 5. It would be a 1 to 32 ratio. In this next example, we have a dilution of 1 to 6 is further diluted down to a dilution of 1 to 9. So this is a situation where you have a dilution of a dilution. And it's asking, what is the final dilution? Well, in order to solve this, we learned earlier you have to use the dilution factors and multiply them. So our first dilution of the sample was a 1 to 6. So our dilution factor is 6. And in our second dilution, when it was further diluted down, we have a 1 to 9. So our dilution factor is 9. So when you multiply your dilution factors together, you get 54. So the final dilution is going to be 1 to 54. That's your final dilution. In this next example, it's asking how many milliliters of serum will be needed to make 200 milliliters of a 1 to 3 dilution. Now, we haven't seen an example like this, but we have to use the information that we're given in order to solve this question. So what is the information that we're given? We're given that we have 200 milliliters of the dilution, and the dilution is a 1 to 3 dilution. So how can we use that information to solve? Well, we're going to take the 200 and we're going to divide by 3 our dilution factor to figure out how many milliliters are in each part. And the reason we can do that is because 200 represents the total volume of the dilution, and 3 represents all the parts in the dilution. So if you divide 3 by 200, you end up with 66.67 milliliters, and that will tell you how many milliliters is in each part. So if we look back at our dilution ratio is 1 to 3. The 1 is representing our serum. The 3 is representing total parts. So have we answered the question that we were originally asked of how many milliliters of serum do we have? Yes, we have, because we've answered how many milliliters are in one part. So one part, one part has 66.67 milliliters, and that's equal to the amount of serum that's in the dilution. Okay, in this example, you're going to be given measurements and you're going to be asked to find the dilution ratio. So if you have 3 milliliters of serum and it was added to 9 milliliters of water, what is the dilution ratio? Again, you have to use the information that's given in order to solve the problem. So we're going to look at the volumes that were given. We were given 3 milliliters of serum and we were given 9 milliliters of water. So we have to figure out how many parts we have in order to figure out our dilution ratio. So we're going to figure out how many individual parts we have. So we're going to take our 9 and divide it by 3. So 9 divided by 3 is 3. So that's going to tell you we have at least 3 parts of water. That doesn't give us total parts, does it? We're going to have to add our serum part to it in order to get total parts. So remember, our serum accounts for 1 part. So you add 1 parts serum to the 3 to get a total of 4 total parts. So when we're writing out our ratio, you'll have 1 part serum to 4 total parts. So our ratio is 1 to 4. Okay, in this example, it's asking you how many milliliters of water are needed. Instead of in the example before, we were trying to figure out how many milliliters of serum we had in a part. So, how many milliliters of water are needed to make 600 milliliters of a 1 to 8 dilution? So the very first thing that we need to do is use the information that we're given to figure out how many milliliters are in each part. So what's the information that's given? We're given 600 milliliters. It's total volume, and we're given it's a 1 to 8 dilution. So we're going to take our 600 and we're going to divide it by our dilution factor, and we're going to get 75 milliliters. And that 75 milliliters is going to be in each part. So let's remind ourselves we're working with a 1 to 8 dilution. And the 1 represents serum, and the 8 represents total parts. So if we were looking for the milliliters of serum, we could stop at this point, but that's not what the question's asking. It's wanting to know how many milliliters of water do we have in the dilution. So in order to solve that, we've got to figure out how many parts of water we have. Well, we know we have 8 total parts, so let's put an 8 down here. And in order to find how many parts of water we have to subtract 1, because we know that the total parts is the serum plus the water. So we're going to subtract this 1 part of serum. So we've really got 7 parts of water in our dilution. So in order to find the milliliters of water, we're going to take the 7 and multiply it by 75. 75 milliliters represents how much is in each individual part. So 7 times 75 is 525 milliliters. So that tells us we have 525 milliliters of water total in the solution. So in the 1 to 8 dilution, we have 75 milliliters of serum and 525 milliliters of water. In our last example for this video, we're going to look at a question that refers to 7-fold dilution. But anytime you see a dilution referred to as a fold, something fold, it's just talking about a 1 to whatever the number is. Like the 7 folds a 1 to 7. A 2-fold would be a 1 to 2. 3-fold would be 1 to 3. So on and so on. Sometimes you'll see a dilution worded that way. So in this particular question, a 7-fold dilution was performed, so a 1 to 7 dilution was performed. What is the dilution in tube 3? So again, this is one where you're going to set up your tubes, and I just list mine in order vertically. And our first tube is going to start out with our original dilution, so our 7-fold or 1 to 7. So the first thing we're going to try to figure out is what's our dilution factor. Our dilution factor will be 7. So remember, in a serial dilution, you have to multiply all your tubes by your dilution factor to get the next dilution for the next tube. So for the first one, we're going to multiply our 7 times our 7, which is our dilution factor, and that's going to be 49. Well, that's going to give us our dilution ratio for our second tube. So our second tube is 1 to 49, and I wrote 42, sorry. 49. And then we'll need to multiply by our dilution factor again, which is 7. 49 times 7 will give us 343. So our dilution ratio for tube 3 is 1 to 343. And that's what our question is asking us. What's the dilution in tube 3? I hope all these examples of dilutions helped you better understand, but if you're still struggling or having trouble with dilutions, please don't hesitate to reach out and ask for additional help.